All right, now we're trying to get to the basics of what we're trying to do here, maximizing product performance. So in Le Chatelier's principle, we can shift it towards the reactants or towards the products. But unlike many of the industry, we're trying to shift to make more products and less reactants. So we want to adjust the conditions to force it only to the right to make more products. So how can we maximize the product if we can manipulate pressure, temperature, and the amounts of products or reactants? Well, let's take a look at this one. So let's start off with temperature. If I increase the temperature, that'll shift away from the heat to make more products. Great. Other conditions. The solid, I don't do anything with. I can't. So this solid I would also ignore. If I decrease the amount of CO2, that means there's less that can make reactants, and more products can be made because this CO2 won't break down to make reactants, so decreasing CO2. Then lastly, pressure. Well, I've got no gas particles on the left and one on the right, so if I decreased the pressure, that would make more of the products. So increasing temperature, decreasing CO2, and decreasing the pressure are all of the factors that will push this to go from reactants to products. Let's look at our second example. I'll start off again, kind of stuff on the left. So increasing H2 and increasing Cl2 will give me more reactants to make products. Excellent. If I look at the pressure, I have 2 gas particles on the left, nothing on the right. So if I want to try to shift it to the right, I would increase the pressure. Lastly, temperature. Since I have energy on the right side, decreasing the temperature will then enable it to react more hydrogen and chlorine to make products. So increasing hydrogen and chlorine, increasing the pressure, and decreasing the temperature are all going to push this to the right. Last example. So we have the ideas of increasing the pressure because I have 3 gas particles over here and only 2. So that's going to push from 3 to 2, pushing it to the right. Temperature, I have temperature on the right side, so decreasing the temperature will shift it towards the right because I'll have less heat to make reactants. And then I look at my compounds. On my reactant side, if I have more reactants, I can make more products. So more carbon monoxide and more oxygen will shift it to the right. Carbon dioxide, if that's removed, meaning a decrease in that concentration, then more can be made. It's like clearing off a bunch of cookies that you're cooling in order to put more cookies. So we have an increase in pressure, a decrease in temperature, and increasing carbon monoxide and oxygen, however decreasing CO2. So let's summarize this to where we can use this kind of concept across any of these. So for the reactants that are gas or aqueous, remember solids and liquids we just ignore, you would want to increase those reactants in order to maximize products. For products that are gas or aqueous, again, ignore any solids or liquids, we would decrease the product concentration for those that are gas or aqueous. For temperature, we would increase the temperature if we have energy as a reactant. We would decrease the temperature if the energy is as a product. Pressure is going to be the most challenging. So changing pressure to shift to the right depends on the number of particles on either side. So if there are less particles in the products, you would increase the pressure. If there are more particles in the products, you would decrease the pressure. If they have the same amount, or let's say none, then pressure will not be changed and there's no change at all. Some final thoughts here. You might go, what does this mean? This is the chemical symbol for diarrhea. Meant to be kind of a gross joke, but let's break it down. What's in this parentheses here is what's called urea, a compound that comes out of your urine. And you might remember from naming, di means two. So urea, di, say it fast, diarrhea. Be sure to answer this final question and come in with anything that you got. See you soon. Bye-bye.